My name is Durga.
Hello everyone, my name is Bishan Khadka.
So today we are going to present nutrition tracking database, and our project goal is to collect and analyze qualitative or quantitative data, to implement all the information on the database table, and to easy access of data information regarding nutrition fact, and to keep track of information regarding gain and loss of weight of the user. So the database description is designed to keep track of nutrition health of the user, which will store general detail like diet plan, calories they consume in specific food, regular weight record, gym record, and exercise record. And also we can monitor his or her weight and calories consumed regularly, and also can keep record of his or her gym activity that will help user for a future exercise plan. So this is the ER diagram for our project, and we have 5 different entities. They are technique, person, weight, gym ID, and food. We can see user ID bars are on the person entity, which is primary key, and the same key is used in technique as primary key, but it is mentioned as foreign key. So and the primary key is again used in weight and food, and we have created different primary key for the gym ID entities. So we have created the database name nutrition, and we are using same database nutrition, and we create table person, and we insert user ID, first name, last name, age, sex, height, protein, and primary key. And this is a snapshot of creating database and table and inserting the values. So these are the queries that were tested. The first one is tribal query. We use select from person order by the first name, and we can see the result. The result is ordered by the first name of the user, and this is the aggregate function. We select sex, count sex as number from person group by sex, and this is the result. And following is a tribal query which return all the column from person table, and the result is also ordered by the first name of user. And this is aggregate function and grouping. For this we select food category, average total categories as average calories from food group by food categories, and this is the result. So the another one is subquery. For this we use select from person where user ID, in select user ID from weight where day of the week is Sunday, and we can see the result like user ID, first name, last name. And for the query B, we create view calories as select person, user ID, concat first name, last name as username, sum total calories as calories from person, inner join food, and person ID equals to food.user ID. This query has created a view called calories for every 5 queries. So for the next time, user will not have to write whole query, as the result can be obtained by just calling the view by using select statement.
Here are the series of queries that were tested. Union statement, we select the user ID from food where total calories was greater than 500 union. Select user ID from weight where user weight is given right here. And here are the results. We figured out user ID. This query returns the union of user ID to those users who have higher weight in the weight table and those who consume high calories in the food table. It's custom stored function. Let's create a function, a food list, UID voucher 10, and returns the voucher 20. Deterministic, and we begin. Can we return? Select the food name from food where user ID equals to UID limit 1 and end, and we select the food list. And here we can see the results of the food list as the snacks popcorn. This query has created a stored function that will return the name of the food consumed by specific user. User ID will be passed to the function. Here we have created a procedure food calories, and it's kind of similar. Begin, select, we have the food categories, total calories, serving size from food where food name equals to first name, and here we can see the food categories, and soup and sauces, total amount of calories, serving size. This query returns the details of food whose name is passed to a store procedure. Users will not have to write different queries for different food names. Right here, here's a tribal query. We select from food ordered by food name. We can see here the various food names such as buttermilk biscuits, cheese NFS, coconut cream cake. We can see the food category, baked foods, skim dairy. Following, this is a tribal query that returns all the columns from the food table. The result is ordered by the name of food. Here's an aggregate function and grouping. Let's select the weekday. Average lost calories is average calories from gym grouped by weekday. We can see the weekdays, they are Monday, Wednesday, Friday, and the average calories over here. This query returns a table that shows an average calories lost in each day. We had various project difficulties. There were various kinds of challenges while running the several queries from the workbench. As even though there were a lot of queries, we had to select each queries and get the report, as there were 20 different queries. We had difficulties during the creation of multiple repetitive queries, as while testing the queries. Some of the tables were already created, and we had to delete them to make sure all the queries ran successfully. So if there's any questions regarding the project, please let us know. It's the end. Thank you very much. It was really a good experience doing this project. Thank you very much.